Chapter 9. Parabolas. Right, so first, so we're going to get straight into parabolas. So we're going to look at parabolas a little bit differently than we did in geometry, or I mean in algebra, actually quite a bit differently. So we're going to start by drawing coordinate plane. And we are going to, there's a whole bunch of new stuff we're going to learn about parabolas right now. And we are going to, this is the y-axis, this is the x-axis. We're going to draw a parabola like that. And right here in the middle, that is our vertex, just like before. And then we have a line, we're going to draw a dotted line here in the middle that goes through the vertex. And this line is called the axis of symmetry. Still nothing new yet. Now, I think everything else is going to be new. We're going to draw a dotted line right here. This is called the directrix. Directrix. And in this case, the x, the way you find the directrix is it's x equals h minus p. We're going to learn what that means in a minute. Your vertex is v, right? Which is hk. And we'll learn what hk is too. Your axis of symmetry is y equals k. Now there's a few more things we're going to draw on this. We're going to find a place right here. We're going to call this point capital P. And we're just going to say this is x and y. And this, the special thing about this P is that if I were to draw a line segment horizontal to the x-axis straight back to here, to this point, this, and then draw this same length of a line down to my axis of symmetry, so that this line is the same distance as this line. This point right here is called my focus. And the focus is a capital F, H plus P, K. Now, this distance from my vertex to my focus is lowercase p. And the distance from my vertex to my directrix is also lowercase p. So this distance from here to here is the same as this distance from here to here. So this would be a 90-degree angle here, this would be a 90-degree angle here. This point M is h minus p y. And that is all of the things we are going to put on this little schematic here. So now we're going to talk about, so this is all new stuff. So let's start working with it. And let's talk about it a little bit more here, and then let's start working with it. For the rest of these notes, generally speaking, we're going to be working with it. Almost. So now we're going to learn what standard form looks like. Standard form for parabolas. Okay, so we're going to have two different standard forms for parabolas here. One is going to be x minus h squared equals 4p y minus k, and the other is going to be y minus k squared equals 4p x minus h. Now, something to notice here. These look almost exactly the same, right? Now, here's the difference. Notice this one has x and this one has y. X squared and y squared. All right? The h is always with the x. The y is always with the k. Y and the k, x and the h. All right? So this one has the x squared and the y not squared. This one has y squared and the x not squared. Now, what this is telling us is, if I were to have, we're going to draw two coordinate planes in each of these things. This scenario, if its x is squared, then we're going to have a parabola that goes up or a parabola that opens down. And in this case, p is greater than 0 or positive. In this case, p is less than 0 or negative. This value here for p, negative or positive. In this scenario here, we're going to have the parabola opening to the right and the parabola opening to the left. If it opens to the right, p is greater than 0 or positive. P is less than 0 if it's opening to the left. Okay, so let's just write a little bit down here, and then we'll move on to the next bit. So your focus is h k plus p. Your axis of symmetry is x equals h, and your directrix is y equals k minus p. Yeah. For now for this one, it's going to be different here. Your focus is going to be it's going to be opposite. But I'd rather not get into this. I'd like to do some examples and not really use these formulas much at all, because I think conceptually it's going to be easier if you don't have this stuff all muddying up in your head. So we're going to just stop right here with this, and we're going to see if we can figure this out and use our brains in a different way without needing these little formula things. So we're going to go straight to an example now and use all of this information that we have found or learned. So determine the characteristics of a graph. And graph, I should say. All right, here's your example. So if I have y plus 5 squared equals negative 12 x minus 2. So based on what we just looked at here, I have this kind of scenario where my y is going to be squared here. Y squared, right? And so I know that my parabola is going to be opening to the right or to the left. Now I also see that this is negative. So that means it's going to be opening to the left. So I already know quite a bit about this parabola. Now, the first thing I want to look at here is my vertex. And so my vertex is h and k. So that gives me, I just look in here, h, I look in my x, and so my x value is 2. And my k value, or the one with the y, is going to be -5. Notice I took what looks like the opposite. Remember, in my formula here, in my standard form for parabola, I've got x minus h, y minus k. Y minus k, x minus h. That means I take the opposite of what's in here, and that is my, those are the values for my vertex. So I just take the opposite of those. So remember that, that is quite important. My focus, I don't know what my focus is going to be yet, but let's find out. So let's start graphing this. So my vertex is 2, -5. 1, 2, 1, 2, 3, 4, 5. There's my vertex. Okay, now the next thing I need is my p value. I need to find what the value of p is, and the way I do that is I look right here at this 12 and -12. And so remember that right here in my standard form, 4p equals whatever is going on right here, so -12. So what I do is I just solve for p. P equals -3. All right, so p equals -3. This is important information and makes this whole graphing scenario way easier. So all I do is I use p, which is -3, but I can ignore the sign here for for my p value. So I just move to the left 3. 1, 2, 3. There is my focus, because remember, this thing is going to be opening to the left. So I move over 3. There's my focus. -1, -5. So my focus is -1, -5. And my directrix is going to be 3 to the right. 1, 2, 3. So 2, 3, 4, 5. There's my directrix. And so my directrix is a line, so it's x equals 5. My directrix is not a point, it is this line. So it is written as a line, x equals -5, right where it goes through the x-axis. And the last thing I want to know is my axis of symmetry. And that's right here. That goes through the focus and the vertex. And so that goes through the y-axis right here at -5. So y equals -5 is my axis of symmetry. Now the only thing left to do is to do a t-table to see how this parabola is shaped here. And so I'm putting x values and y values here. I'm plugging in some values for x, 0, -1, -2, -4. And if I plug these values in here to my original equation, then I can find out my y values. So each of these y values, you're going to end up with 2 y values for each of these x values. So I'm going to plug in 0 and show you what I mean, and then I'm just going to fill in the information right here for the rest of the y values. So if I plug in 0 for x, I get y plus 5 squared equals -12 0 minus 2. So now I have y plus 5 squared equals negative 2 times negative 12 is going to give me positive 24. I take the square root of both sides, and so I have y plus 5 equals plus or minus the square root of 24, which is approximately 4.9. And so if I subtract 5 from each side, then I end up with y is about negative 0.1 and negative 9.9. So if I subtract 5 from negative 4.9, so here's what I'm doing here. I've got negative 4.9 minus 5 equals negative 9.9, and since I need to do the positive one, positive 4.9 minus 5 equals negative 0.1. So if I plug in 0 for x, I get negative 0.1 and negative 9.9. And I do that for all three of these left over, and I would get 1, negative 11, 1.9, negative 11.9, and 3.5, negative 13.5. And then I plug, just put all of these points in here. So at 0, I've got negative 0.1, which is right about here, and negative 9.9, so 5, 6, 7, 8, 9, almost 10. So that's what this part of the graph looks like. I'm going to do this negative 4 here. Negative 4, 1, 2, 3, 4. 3.5, 1, 2, 3 and a half, and negative 13.5, 10, 11, 12, 13.5, there. There. Now we have the general shape of this graph. There it is. That's all there is to it. So there's the focus. Okay. There you have it. Now we are going to look at writing this in standard form, or, oh, you know what, actually,